keep us on schedule. Okay, so let's get started for the second half of the tutorial. So now we're going to talk a little bit about vector formats, and most of the rest of what we're going to do is about vector data. So we'll talk briefly first about using OGR. That is the vector processing package that's built into GDAL. It's part of the GDAL distribution. So if you have GDAL, you have OGR. And it has lots of command line utilities to deal with different kinds of file formats. And here's the most common thing that you're going to do with OGR is you want to translate one kind of file to another kind of file. I'm going to say right now, if you're just doing a simple translation, there's no point in doing that with Python. If you just want one file in and another file out, do that from the command line. Call OGR to OGR. Give it a file format. Here, this command just converts a shapefile. This is a public domain shapefile from the natural Earth vector data. There's a link in the data directory. I don't remember whether I committed the actual shapefile, but you can download it. And I did commit the GeoJSON output for this shapefile. I think there's a typo there, isn't it? Oh well. And any supported formats, I think some it can write and read, and others it can only read. But for the supported formats, going between them, OGR to OGR is great. GeoJSON, I'll just point out, as a vector format, is getting to be pretty popular. Is a really nice, simple JSON-based format. And the big news on GeoJSON in the recent last couple of weeks is that if you commit a GeoJSON file to a Git repo, it's actually visible as a map automatically when you look at that file on GitHub. So I committed this to my repository in the data repo, and it has the boundaries for all the countries in the world. It's just that file that I converted there and uploaded.
Was OGR to OGR included with when we installed GDAL?
Yes, it should be. So if you got your path correct, it should do it. Let's see which one I'm using. Whoop.
What's the difference between OGR to OGR and GDAL translate?
Raster and vector. The OGR is vector. Yeah. Okay. So I'm using the binary that is in my Canopy install right now, but I believe I have one in user local bin. Yeah. Okay. So wait, which one is that?
So I've got OGR to OGR.
Yeah.
It's executable in that path, but it seems to be trying to load a library that doesn't exist in user vagrant account.
Oh, that's a bug. Okay. Is it actually? Okay. You know what? I think that might actually be the case for mine too. I'm gonna demonstrate an end thought bug in front of everyone in public, right? I think this is an issue. Okay, so CD data. There's the shapefile is in this. I just don't remember did I commit this to the repo, or is that this directory is there? Okay, so you should be able to do this as well. So there's the shapefile. You can see a shapefile is not really a file. It's got what, 4 or 5 files associated with it, right? So these depending, yeah. So the projection is there. So you, in general, you point to the SHP file itself, but it has these associated metadata files that have to be there or it won't work. So shapefile format is sort of funny that way. If I do OGR to OGR minus F GeoJSON, call it test.json. Oh, and for GeoJSON, you usually just give it a .json suffix file. extension. Instead of GeoJSON, it's generally used. Okay, and will this work? Oh, okay, so mine works. So I have seen that issue, though, that is a build system artifact of our Python build. So I don't see that issue in my OGR to OGR, but I know it exists in some tools. We're working on it. I'm aware of some of those. But. Other people have OGR to OGR working? Is that the command line works for you? You can run a shapefile and get another format out?
We got MSVCR90.dll is missing from your computer.
Oh, okay. Is that, and which GDAL do you have? How did you install GDAL?
From the binary from Chris.
Oh, okay. Yeah, I don't know that then. All right. Well, the thing is, we'll see if it actually works with the Python bindings. If you're not linking to right libraries, it's not going to work for Python either. Actually, let me go here. All right, so the Python bindings, if you, again, you from OSGeo import OGR, and now to look at the OGR drivers that are available, it's similar to the way you do it for the GDAL drivers. So here, the get driver count method, we're iterating over all the drivers and getting them one by one, and look at all of these, and it's 100 and some different drivers, I think, in this version. I can probably actually take this over to a Python prompt, but I've got a couple dots in there. Oh. So from OSGeo import OGR. Okay, so there's my list, and I could say, well, I can actually say, okay, so, whoop, what am I, oh, I didn't, oh, no, I didn't output it. All right, well, let's do this differently then. I'm just trying to, I was going to get the whole list, but we just want the driver count for now. Let's just get that. Okay, so the driver count, oh, it's 43. So 43 available vector drivers in this version of OGR. Again, that's dependent on your installation, how many flags you chose and libraries you linked to, and so on. Okay, and then I have an example of reading a vector file with the OGR Python bindings. So let's take a look at that. That is in examples, OGR read. All right, so this is my OGR read example. OGR has the same issue that GDAL has with exceptions. If you want to have exceptions enabled, you have to do it explicitly. You can, let's see, we can open a shapefile like this and inspect the layers in it. So this is going to iterate over all the features in layer 0. So each feature you can think of as like a row in a database in the shapefile. Every feature has some attributes, including geometry. So this feature could be a point or a line or a string or something like that. So any kind of vector data that can be represented in, and it might have other attributes associated with it. In this case, I am picking out one field called rock types. So there's a field in this vector data it's called rock type 1, and I'm appending it to a list of rock types. field by field. Now, I'm checking to make sure that the name of that field is actually rock type, and then getting it by index number. I don't think you can reference it directly by name. So you need to know the schema of the data. You can get that, just you can't refer to it by name. Okay, and then it's looking through all the geometries here, and it's also checking to see if it's a polygon. So if the geometry of each feature is a polygon, then it will output all of the rings that make up the polygon, which may be one exterior ring and 0 or more interior rings in a polygon, and writing those out to a list of polygons. So let's try this. Okay, so it worked.
So the stuff in the repository blew up because the data is zipped up and not in a directory.
Oh yes, sorry. So you have to manually unzip this file. So I've got a little comment here, but I didn't do that explicitly. I think I did try to do that in the other exercise.
And put it in a directory called NJGL, whatever.
Yeah, correct. The same name as the zip file, base name. Yeah. If you run I think there's an exercise. The exercise we're going to run here. From the exercises directory, there's a geology exercise. This actually attempts to do that unzipping for you. So if you run the stub exercise geology.py, that will unzip this file to the right place, hopefully. Again, it's not thoroughly tested, but it works for me. So hopefully that works for you. If not, you manually unzip it and put it in the right place. So given that that's unzipped, this OGR script has looked through, and here we can say len rock types. So we have 3,561 rock types in this file. So that means for every feature, it's got a rock type. And if we let's just look at what some of those rock types are. Look at the first 10 rock types, say. Limestone, siltstone, black shale, limestone shale. Okay, so this is a geologic map of New Jersey. And these are polygons for different bedrock types. So we see there's 3,561 rock types. There's 4,258 polygons. So there are more polygons than rock types. There are two ways, the way I've written this loop, that they could not match up. First of all, there could be a geometry that's not a polygon. If there's a geometry that's not a polygon, then it won't find a polygon. But there are actually more polygons than there are rock types, which means it's getting multiple polygons written for each rock type. That is, each feature has multiple polygons. So some of these polygons have inner rings, right? So the meaning of a polygon in this sense, and this is the standard for vector data, is that a polygon is an exterior ring and 0 or more interior rings. So you can have holes in your polygons. You can define donuts and multiple hole objects.
Could a shapefile ever have more than one layer?
Yeah, right. So you can have.
In what case would you see that? What's an example of that?
I mean, I think there are a lot of I guess the analogy is like a database. Multiple layers are like multiple tables, right, in a single file. So they can represent different data sets. They
so you can have a layer be a polygon, another layer be. So I'll give you a meteorological example. A polygon of, let's say, wind speeds from a storm, but then another layer be the individual lines of the path of the storm.
You can store that in a single shapefile?
And you can put that in a single shapefile.
May I see one of those?
Unfortunately, I'm not allowed to give you.
I'm sure you can find examples in the wild, though. That they're yeah.
Units where in a single shapefile, generally it's not a practice you see.
But yeah, you usually make them separate shapefiles, but you can
Yeah.
small. Yeah, it's not a good practice.
Yeah, I guess I would say that it is best practice to put one layer in, and then it's clearest to move those around and deal with them separately. But it's perfectly legal to layer those in the same file.
Part is because the conceptual model of OGR is that there are many formats that do natively support multiple layers in a single data store, and it's just a way of keeping it back.
Yeah.
Not just
Oh, is it not a standard in a shapefile? Oh,
I don't want
okay.
to say you can't do it.
Oh, okay. All right.
It's definitely not just back of the file.
Okay.
If anyone knows, give me a link to a shape file that doesn't have more than one layer, I'd love to see.
Okay. Okay. In any case, this particular shapefile we've extracted all of these polygons. Some of them are exterior polygons, some of them are interior polygons. I haven't distinguished between them in this list. And now if I look at polys, right, is that what I call it? Polygons, right? Polygons is my list. I look at the first item there, and I've stored it as a list of tuples of coordinates, right? So we can just deal with those. All right, so this works. You can read shapefiles and other vector formats just fine with the OGR bindings. It's a little bit awkward. Here I have to find the right field and get that field and so on. I think that the currently nicest library to deal with these kinds of issues in Python is Fiona. Fiona is a Python package that wraps the OGR libraries, but gives you access in a Python-friendly way. And this is what a reading a shapefile looks like. This comes from the Fiona examples. So this file isn't in my repository, but it should be in a Fiona source repository if you've downloaded that. But this would work the same, and we'll do this shortly on our file. So here you open a file, and to get a single record on it, there's an iterable on this file handle, and we have that record has keys, is a dictionary that you have dictionary-like access on each row of your file. And then that row has a geometry. Right. I think, yeah, those are properties, isn't it? I think that doesn't actually match up. So let's, well, we'll see an example here. But you can extract the coordinates directly as a tuple, as a list of tuples in coordinates. Here in this case, it's a polygon in the geometry. So let's look at this IPython notebook example. Okay, do I have an IPython notebook running? I do. No, that's there. Okay, so just a second, let me find my notebook. Too many tabs. Where's my tab?
Does anybody have a successful install of Fiona against Canopy? Because mine blew up.
Okay, so yours doesn't work?
Yeah, it's the same for me actually. I was not able to build it. It's asking for where GDAL is.
Yeah, that's right.
Yeah, and some system installations don't include GDAL config.
Yeah, that's right. So there's a bug in the Canopy GDAL config. It exists, but it points to something nonsensical, which is an artifact of our build system. It doesn't point to the actual install libraries. So you can compile it to those libraries, I think, but yeah.
Iterating the GDAL,
Yeah.
stick file that points to the right location.
Yeah.
Then it worked, but even then it only worked when I went from canopy 32 to canopy 64.
Okay, yeah. Well, if the binaries are consistent, it should work on either, but it might be environment dependent, yeah. Yeah. Okay, how many people have a working Fiona install on your machine now? So maybe half, a little less than half. How many people tried and don't? Okay, yeah, half-ish. Okay. So for the exercises coming up, you can do them through the OGR interface. So just look at this example and get the polygons this way instead of through Fiona, right? So that's one option, or we can pair up with people that have working Fiona installs and just sort of work over each other's shoulder when we get to that. But let me show you an example of what Fiona really looks like running it. I'm gonna just start this over again. Oh, there was the address. Oh well. All right, I'm gonna start up a new notebook, server. Okay. So here, I'm just gonna open this in my Chrome and do the same. Okay. So here's my notebook. This is the one that's in your repo. So now this is looking at a different data file. And again, you might want to look at this path, but this is looking for the path relative to where I started up this notebook, which is where it's located. So this is probably a little bit brittle, but this is supposed to point to the data directory in this checkout. This is the New York borough boundaries, and this is the shapefile in that directory. This HP file. So here, C equals Fiona, open shapefile. Let me actually just clear all output, and we will run it step by step and see that it works. So I will evaluate my first cell here. I open the collection, see how long is it. We can get a length on it. It's 5 features in this set. So that is the 5 boroughs of New York. Driver tells us what OGR driver is using underlying it. That's the Esri shapefile driver. The coordinate reference system, this is a dictionary version of the PROJ.4 parameters for this projection that it's using. So you can use this dictionary to reproduce an exact projection to convert it. Yeah. PROJ.4 is the projection library that PyProj uses and other tools. Actually, it's underlying basemap as well. It's the most used open source sort of projection tool. Most of these tools are using that underneath to do that. Okay. Now there's some functions built into Fiona. I'll have to import them separately that act on these CRS objects. So I can say toString. Now this is an actual PROJ.4 string. So you could pass this as parameters to a PROJ.4 call or when in PyProj or outside of it, and this would be able to reproduce this projection exactly. And then taking a Proj string and turning it into this dictionary. This is just a direct mapping of these to dictionary. So this is Fiona's dictionary storage of those parameters. And it can also do shortcuts from EPSG references, right? And that'll just call it init EPSG because that's how Proj will understand it. Okay, now we've got this open collection, and that's an iterable object. So calling next on it will bring up the first record. And each one looks like well, it's a dictionary-like object that's analogous to a GeoJSON feature. So the keys in this record, we have geometry, ID, and properties. So the properties here are you can think of these as metadata for the shapes, or you can think of them as columns in your table. This is data about, here in this case, this is the first record. So this first record has a borough code, which is 5, or borough name is Staten Island. It has an area and a length. And those are not computed, those are stored in the file, right? Those are the things that are there in the shapefile. The geometry has type and coordinates, again, dictionary-like, and we can see the geometry type is a multi-polygon. That means there are multiple polygons, associated as a collection here. And now I'm going to plot all of those polygons. So again, we're still acting on this current record, which is Staten Island, and just plot the coordinates of every record here. And here I printed out the shape. So here we've got a 47 by 2. These are all lists of tuples. So we're converting it to an array here. So they're n by 2 arrays. So we have 47 points making up this small polygon, 9 points, 58 points, and then the 8,910 points is obviously the mainland of Staten Island here, this outline, which is loaded. And here I've just plotted it in X and Y. I'm not doing it in base map. So those are projected meters, projected feet in the New York City grid. And they're just the native units that are in the file. Okay, there's a filter method built into Fiona, and there's some other nice tools built in to do different kinds of operations. But we're just going to mostly use it for simple file reading. All right, so people who have Fiona on your system, the notebook runs all right? Okay. So I assume that should work on the same.
You run in the same set, going back up to the record T next, we'll get the next borough.
That's right, yeah. That's right. It's already, so that's the thing about the notebook. It's acting on the same kernel, but the state can change depending on when you execute it. Yep. All right, let's go. Let's see, we're at 3:45. Let's try this exercise. I don't want to get too bogged down if people don't have Fiona running, but what I suggest is you pair up with someone who has Fiona on their machine and you run that exercise on that machine rather than trying to get the OGR reading working right now. I think that's going to be a little bit too much overhead to get done. But let's look at the geology exercise. So, well, this is an example of the output, but we're going to read this same shapefile, the Geology of New Jersey. This is downloaded from the USGS, and these are some hideous colors that I randomly generated to go with the geology map, and you can try to do better if you like. I actually have a better color version. Here we go. Whoop. So this is a version where I've included neighboring states, and this is overlaid on a Google map. So this is the same data, but now has gone through some processing steps with PostGIS and is loaded into Google Fusion tables, and we're seeing it on a web map. So these colors are now consistent, so you can see the same rock types and so on. In the Python exercise, I've just got, oops, I got here. It just chooses random colors in my solution. If you've got something better, go ahead. But let's take a look. Whoa, where's Canopy? Okay, so let's go to the exercises. This is Geology.py. That's the one that does the unzipping for you. And here the problems are create a list of all the unique rock types in the data. So you could actually see how that's done in the OGR example script as well. You could get that from there if you like. Calculate the total area of each rock type by summing the property area. All right, so you'll be accumulating the area value on multiple features in that case. And then plot the polygons in the data with base map and color it by primary rock type. So this you can do two ways. This is matplotlib patches. Or there's also a package called Descartes, which handles geometry loaded from these kinds of files in a little bit cleaner way. The polygon will be fine as long as we only worry about the exterior rings and not the interior rings. So don't get too hung up on plotting the colors. You just try plotting the outlines. That should be simple enough first. If you just plot the outlines, that'll be a straight plot. You can do it in basemap or in just straight matplotlib. Okay? So go ahead and give that a try and try to find a neighbor with a working Fiona that you could look over their shoulder and help with.